in school that does? 29. I was close. While you were getting that page out, I will take this time to remind you that you indeed have a big old test tomorrow on all things exponent. I do not remember how big that test is, so do not ask. I do not remember how many multiple choice questions that test has, so do not ask. I do not remember how many open-ended questions that test has, so do not ask. I do not remember how many questions on that test apply to real numbers as opposed to exponents. I do not remember how many questions on that test have fraction exponents. I do not remember how many questions on that test have variable exponents. So don't ask. But know how to do all those things. Okay? Okay. All this in brains too. We move on to radicals. Now, to move on to radicals, you should remember the following. X to the m over n is, I shouldn't have written it that way. I should have used the same letters as here. Oh, that's good because I wrote something that was wrong. Don't worry about it. I don't need you to work or nothing. It's cool. You don't need to actually do what you're supposed to do. Anybody can do that. It's much more of a surprise when you don't do what you're supposed to do. Okay. We remember that x to the 1 over n, any fraction, gives us n root x to the first power. That is what is going on right down here. Okay? Now, I will remind you of a few things. I am circling A in red. I'm going to be using red ink to define A. A is a coefficient. I've used that word a lot. I'm reminding you of what it means. If you don't remember, you should. What math does a coefficient do? Multiplication. Coefficient, just like an exponent, or similar to an exponent, a coefficient multiplies what's immediately to its right. And only what's immediately to its right. Okay? Everybody cool? Here's what I mean by that.
Please excuse this interruption. Grade 9 students and Mr. Van Bleichenberg, Mr. Wimmer, PE students, and any students who have missed, please come to the rotunda for polling.
2x means I have x times 2. 2xy means I have xy times 2. 2xyz. X times y times z times 2. Soon as I put another sign, the coefficient stops working. All right? Plus 3. That coefficient only applies to x, y, z. Unless what? Brackets. Just like in exponents. If that's bracketed, now the 2 applies to everything. We all remember this from grade, right? Okay. That's what a coefficient is. Now, the other two things here also have names. This little number is called the index. If you were in grade 10, you should know that already. We use slang for it. We say it is the root. That's not really what it is. The index is its proper name. And that tells us the groups of like factors we seek. And I'll show you what I mean in a minute. Where do we seek those? From x, which is called the radicand. All three of those words coefficient, index, and radicand, I'm going to be using all the time because that is what those three things are called, okay? This is not the little number on top of the sign. This is not the big number out in front because this is no longer grade 5. I will call things what they are actually called in the math world. Everybody okay with that? Good. An entire radical. What color do I feel like writing with today? Dusty rose. Dusty rose it is. An entire radical has no coefficient. A mixed radical has a coefficient, and that coefficient comes from factors of the radicand. Now, all that's a bunch of math stuff, but of course, as always, we show you what to do right now. Now, in this space right here, I want you to split it into 3 blocks. All right? Over on the left here, you are going to write the square root of 72. Now, if you don't remember how to do this, I'm going to show you the easiest way to do it. If you don't remember it, you're going to want to learn this. There is many, many kinds of shortcuts, and I will not show you them all. Some of you will have learned a different way to simplify these than I am about to show you. You are allowed to do that, okay? All right. Step 1. Never again will you push square root 72 on your calculator because it will give you an irrational number. It will give you a whole number and then a line of decimals. We do not want that anymore. So I warned you of that in grade 10. I'm reminding you of it now. You will almost never in math class actually go square root 72. Okay? What we do is we simplify this by breaking it down. 72 breaks down into 8 and 9, or 12 and 6, or 36 and 2, or 18 and 3, all kinds of breakdowns, yes? 8 and 9, 8 breaks down into 2 and 4, 2 breaks down into 2 and 2, 9 breaks down into 3 and 3. And when you get to all prime factors, you can stop. Because this is the same as the square root of 2 cubed times 3 squared. Is everybody remembering this? Now, 2 cubed, there's no little index there. When there's no index there, the index is a 2. Now, I reminded you up here, the index tells me the groups of factors we are seeking. So since it's a 2, I am looking for groups of 2. Are there a group of 2 2s there? Yes. So I will bring out a single 2. There were 3 2s, so that means I left a 2 under there. And now there's a 2 out front. Is there a group of 2 3s? Yes. So I will bring out a 3. So now I have 2 numbers in front, which means they're both coefficients. What do coefficients do? Multiply. 6, 2 times 3 is 6, and I left a 2 under there. I left a 2 under there. Thank you. Underwear? Okay. I know it is. Now, of course I said there's a shortcut. You can also do this. 72 is 36 times 2, and you can stop there. Why? 36 has a square root, doesn't it? What is it? 6. So out comes a 6,
for
and a
any
2 stays
staff
under
or
there.
student
Does
who have
everybody
been
remember this?
taken. Last call.
Good. Now in this block, I want you to put a little 3 there and keep 72. What's changed? The index is a 3, which means I am no longer seeking groups of 2. What am I seeking? Groups of 3. But we do the same thing because math makes sense. We break it down and it's 2 cubed times 3 squared. Is there a group of 3 there? 2. So out comes a 2. 2 cube root 3 squared. Now 3 squared you can leave like that or you can write it as 9. Does everybody remember this? Now of course you should also notice something. If there's a 3 there, 2 cubed, I'm able to bring out the 2. I can just check right there with the index and all the exponents, can't I? Over here, 2 is an index, so I'm looking for groups of 2. So 2 to the 3, I can get out a 2, but there were 3 2's under there, so I left a 2. Everybody good? So this, simplified, is 2 cubed root 9, or 2 cubed root 3 squared. Everybody good? Now, change this last one to 4 root 72, which means I need a group of how big? 4. Is there a group of 4 there? No. So it doesn't get any simpler, so we leave it as 72. Is everybody good? Does everybody remember the easy ones? Good. Do A, B, C, D, E, F, G, A, B, C, D, E, F, G now. Go. You can work with friends. I do not care. Yes. Everything is highlighted in blue. Does anybody need to discuss any of these nice, fairly low-key, easy ones? G. Okay. So I like to check with perfect squares, and I have them all memorized. So up to 20. So I go to...
Staff, this is the last call to come down and have your picture taken. Any students that still need to come down, please do so now.
And also, being comfortable with multiplication, I can see that 3, 6, and 3, 363, will divide by 3, yes? 121 times 3 is 363. 121 I know is a perfect square. So out comes the 11, and I left the 3 under. Everybody is good? Excellent. Turn the page over. Now we're going to go the other way. Write as an entire radical. What does that mean? No coefficient. If there's a coefficient out in front, gentlemen, shut up. Know how I say I'm going to let you sit together until you piss me off? Every time the 4 of you sit together, I'm telling at least 2 of you to shut up. Do you think that is not pissing me off? Good, you understand that, and yet you are continuing to do the same behavior, even though you do not wish to have this lecture. That is the definition of insanity. Don't repeat behavior that gives you a result that you are not happy with. Okay? Kind of like if I was hitting myself in the head with a hammer, I would stop because it frickin' hurts. And then I wouldn't do it again. Because I'm not crazy. Okay? I know you all want to sit together because as soon as I say work with your friends, you 4 sit together. Nobody else moves but you 4. And you'll notice I don't speak to anybody but you 4. You think there's a connection there? I'm a smart guy. I can figure it out. Gots me? Good. there is no coefficient. If there is no coefficient, I don't want there to be a coefficient. If there is a coefficient, originally, the coefficient was part of the radicand, yes? Because the coefficient is always built from the radicand. So in this very first question here, I have a 2 out in front, which means there had to be some 2's under there, yes? How many 2's? 2, because this little index here should have been a 2. So this is really the square root of 5 times 2 squared, because there had to be 2 2's under there, yes? 5 times 2 squared is the root of 20. Yeah? Now, you should already have seen a little shortcut. If there is a coefficient out front and an index of 2, we put that coefficient squared underneath, didn't we? Okay, so what can we do here? There was a 7 out front. There should be a little 2. So what does this become? 29 times what? 7 squared, which is 29 times 49, which is 1,421. Everybody cool? Great. What's C? Square root of 4 times 6 squared, which is the square root of 144. And what's D? D is very tricky. D is very tricky. Who has an answer for me? Negative root 300. Why? If you bring the whole negative 5 under there, doesn't it become the root of 12 times negative 5 squared? Everyone agree? What is negative 5 squared? That is the root of 300, correct? But our original value was negative. The root of 300 is a positive number, isn't it? So that is why I have to leave this negative out in front. Is everybody with me? Is that always the case? No, because if I want cube roots, can I have a negative number under there? Yes, because the cubed root of negative 8 is negative 2. Everybody cool? If I have a 4 there, can I have a negative number under there? No, why not? Right. A negative to the 4th power is going to be positive, isn't it? So I can't have a 4 under there. That's not cool. Can I have a 5th root of a negative number? Yes. Can I have the 6th root of a negative number? I know it just died. You can answer the question, though. Can I have a 6th root of a negative number? Yes or no? No, because negative, 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 negative is positive, 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 isn't it? So what's the shortcut to remember? Odd exponents will allow for a negative. Odd indices will allow for a negative. Pretty cool? All right. Now, who remembers how to do number 3? Because I'm a meanie. Because I said no calculators. Talk to your neighbor. See if you can remember how to do that. Go. Hey. How do you do this without a calculator? There's a couple of ways you could do it. Would anybody like to volunteer their way? Anyone? You have the answer, but you don't have a method. You must have done something to get an answer. You can't just go,
I turned the coefficients into
yeah, so you had a method, right? Louis' method was to turn all of those into entire radicals. So this first guy, if there's a 7 out in front, what was underneath? 49. So that first guy is the square root of 98. What's the next one? Square root of 75. What's the next one? It's already 14. What's the last one? 9. And then the last one is 81. Right? Sorry. 36. It's just 9 right there. 9. No. There's no square root there. It's just 9. So, put them in order. Well, we know that's 3, don't we? Or, what else is it? Now, yeah, root of 81. It's also the root of 81. Now, it's easy, right? What's the smallest?
14.
Root 14. So that's 5 root 3. What's next? 3 root 4. Yeah, it is just root 14. 3 root 4. 1 second, Jazzcarn, I know what you're saying. Keep going. What's next? 5 root. See, a bunch of you put 5 root 3 first. What's the smallest number there? Root 14. Then what? Now what's next? Root 36, which is 3 root 4. What's next? 5 root 3, which is root 75. Then what? 9. Then what? 7 root 2. Now it's in order. Everybody good? Is there another way you could have done it without a calculator? You could have estimated, right? If you have these numbers memorized, it's not, you could estimate, right? I wouldn't recommend it. I would recommend this. Is everybody cool? Great. Do the next 6. What's different on the next 6 than the first 7 you did? There's different indices, right? So I'm looking for different groups of factors. The first 7 you did was all groups of 2. On this one, it could be 2, it could be 3, it could be 4. Everybody cool? Go. There are the right answers on the board if you wish to check. If you need to ask, ask now. If you don't have them done, you can either copy them down now or continue to work without looking up. Yeah. As you can see, I don't show any work because I'm doing these in my head. It's entirely possible I made a small multiplication error.
Sorry for interruption. May I excuse a request from those requests?
Sure. Lucas.
Sorry.
No problem. Everybody good? Everybody got those 6? Everyone's good? Okay. Now, you should have a bunch of white space down here, yes? Those of you who've been in my class before know I do not waste paper, do I? Down at the bottom here, we're going to do our first thing that will seem new but isn't. Okay? 1/2 root 32. How will you simplify that? No, I said you're not going to be using your calculators for this anymore. Because you will not be hitting root 32. This is a problem that bothers math teachers. Because a great many of you are looking at that like, oh, that's weird. What could I do? Because you're not thinking about what is actually happening. would you all know what to do if I had 3 root 32? What would you do with the root 32? You would simplify it to 16 times 2. And what would you do with the square root of 16? It would come out here, it would be a 4. What's already there? What's 4 times 3? Because they're now coefficients. 12 root 2. Yes? Okay, so you all know what to do. So what are you going to do here? You're going to do the same thing. 16 times 2, what's coming out? 4. So what's 4 times 1/2? 2 root 2. Everybody cool? Easy peasy, because half is a nice one to work with, yes? All right. Here is what bothers us math teachers. You people often do not see what I'm about to write. You don't see this as 1/2 times root 32 over 1. Everybody cool with that? Now, if you were, well, it's 1/2 is a coefficient. Coefficients multiply the next thing, right? So 1/2 times. Now, the denominator of something is always 1 when we don't write it, correct? So this in red is the exact same thing as this in black, yes? Now, so what is 1 times the root of 32? Root 32 over, what's 2 times 1? 2. If this equals this, and this equals this, then what do you know about that? That they're the same thing, yes? So I'm allowed to write root 32 over 2. Everybody cool? Now, what would you do with the 32? You'd simplify. That's 16 times 2, so it's 4 root 2 over 2. And then what do you see right there? Just like in exponents. 4 divided by 2 is 2, and I get 2 root 2. Everybody cool? This step, for some reason, is tough for you folks to see. Are you okay with it? Now, half made it easy, right? So what then if I had 2/5 root 75? What could you do with that? You could simplify here, bring it out and multiply, right? Or you could recognize that this is 2 root 75 over 5. And then simplify here, keep your numbers nice and whole and easy to work with until the end. Does everybody understand? Jazzcar. Pardon me? That's explaining what is actually happening here. 1/2, there's my 1/2. It's a coefficient, so it's multiply. And root 32 over 1 is what that is. Because every number is always over 1. Yes, you could. So I just skipped that step because this is why this works. I went straight from there to there. This is why it works. So I could have gone here 2/5 times root 75 over 1. Then I get 2 times root 75 right there over 5 times 1, 5. Now, when I simplify this root 75, I only have a whole number out in front, not a fraction. Because a great many of you screw up multiplying whole numbers by fractions. Okay? So, of course, this is 25 times 3, right? What's the square root of 25? So what comes out? 5. So what I really have here is 5 times 2 root 3 over 5. Well, what happens with the 5s? Cancel out, and there's my final answer. Everybody cool? Now, the problem that you people have is you don't like showing work. And by not showing work, you're actually making more work for yourself. Okay? Because if you leave this here, it's going to be tough tougher to get to here. Is everybody cool with the fractions? Okay. Turn the page over. So now, I want to remind you when it was 2 square root 3, and we wanted to go back to an entire radical, it became 3 times 2 squared, right? I took the coefficient and the index, and I used it to make this. Everybody remembers that, right? If it happens once in math, how often does it happen? All the time. So, if I'm allowed to take the coefficient and the index and put them under the radical sign when it's a 2, can I do it when it's a 3? Sure I can. Cube root, the 4 was already under there, and what's going to be here? 3 cubed. 3 cubed is 27, so that is the fourth root of 4 times 27. So it is the third root of 108. Everybody cool? What's going to happen in B? Same thing. It's going to be the fourth root of 5. That 4 looks like it's a coefficient. Fourth root of 5 times what? 6 to what power? The fourth. Fourth root of 6 to the fourth is 216, 1296. 1296 times 5 is 6,000, and 96 times 5 is 450, and 3480, so it's 6,480. Right? Somebody will corroborate that with a calculator. You're giving me a thumbs up. And this is 7 times 5 cubed, which is 7 times 125, which is 825. Is 875. Sorry. Is everybody good? Yeah? Okay. 6 more. Go. And remember, there's some blank space at the bottom of the page. We're going to be doing some work there. Yep. The 6 right answers. The first 4. Anybody want to talk about any of them? Usually people are like, oh, why didn't you change that one? Because it's the square root of 3 times 7 times 5, isn't it? Any pairs? So you got to leave it. Where'd the square root thing go? Well, that's the square root of 2 squared times 7 squared, isn't it? So what comes out? A 2. What comes out? A 7. 7 times 2 is 14. Did you leave anything under there? So, there's nothing there. So that's why it's 14. Everybody okay with these 4? C. Okay. So what is your preferred method of doing these, Louis? Do you like to break them down? Yeah. Okay. So 432 is an even number, yeah? So I'm going to divide that by 2 to get 216, right? Then I'm going to divide it by 2 again to get 108, right? Then I'm going to divide it by 2 again to get 54, right? Then I'm going to divide it by 2 again to get 27. Can't use 2, but I can use 3, 9, 3, 3, right? Yes? Oh, of course. Please do. But I should warn you, Lucas, you should not be wearing your hat.
Why not?
Because it's a school thing and someone will yell at you.
I didn't know.
And then what they will do is then come and yell at me.
Oh, sorry.
Why are kids in your class wearing hats? And I'll be like, all right. So, Louis, since I'm looking for groups of 3, is there a group of 3? Is there a group of 3? So out will come a 2. Out will come a 3. 2 times 3 is 6. And what this lonely little 2 was left under there. Cool? Now, I could have stopped right here because I have memorized the first 10 cubes. And I know that the cubed root of 216 is 6. So I can stop right there, bring out the 6, and leave the 2. Okay? Everybody okay with the rest? Until F. F's a problem, yes? Oh, and E. Well, E is just dividing, Ayaka. You just have to figure it out. 384 divided by 2 is 192. Divided by 2 again, blah, blah, blah. And you just find your pairs. F. 180 is 18 times 10, right? Which is 9 times 2 and 2 times 5, right? Does 9 have a square root? 3. So out comes a 3. And there's a group of 2 right there, right? So out comes a 2. So these are all gone. 5 was left under there, yeah? What was already out front? 2. 3 times 2 times 2 is 12. And there's a negative out front, so I got to keep the negative. Okay? Everybody can do this with numbers now, yes? All of you remember grade 10. No matter what I do with numbers, even if it takes a while, you'll figure it out, right? Okay. In the white space at the bottom, we are going to work now. Once we learn something with numbers, what do we do in math to mess with your head? Turn it to variables, right? Okay. So, explain to me why the square root of 9 equals 3. You don't need to write it, John. Just explain it to me. Why is that the answer? 3 times 3, and that's my group of 2, right? So everybody gets that, yeah? This is the root of 9 equals the root of 3 times 3. Out comes my pair. To get 3, and I left nothing under there, right? Okay. What then is the square root of x squared? Why? Because that is x times x. Out comes my pair, x, and I leave nothing under there, yes? Everybody cool? Okay. What is the square root of x cubed? X root x. Why?
The root just square.
X root x, because this in the middle here would be x, x, x. And it would be naughty, right? Everybody got it? Okay. What then, logically, is the cubed root of x to the 5th?
X square root 2.
Cube root x squared. Does everybody see where we're going here? Right? Can you see a shortcut? 3, 5. There's one x out front and 2 x's underneath. 2, 3. There's one x out front and 1 underneath. Can everybody see how this works? So what then is the 7th root of x to the 9th, y to the 10th?
X squared and
Just x,
squared.
x, y, 7th root, x squared, y cubed. Is everybody good? Please notice, the 7 means I'm taking out groups of 7. 9 minus 7, there's one group, so out comes an x. But I left 2 x's under. Everybody cool? Everybody? Okay. So now, if you're really starting to understand this, what is the square root of 81 x cubed y to the 5th z? Don't say it out loud. Think about it for a minute, because some people think a little bit slower. Let them have a chance. Think about it. And now, who would like to offer an answer? Ayaka. 9 x, y.
Y squared.
Not quite.
Q.
Not quite. Oh! Now you're still not quite right. Damaris.
9x y to the 2.
Squared.
Y squared.
Root.
X y.
That's right. Why? Because there were 5 y's and I was looking for groups of 2. So in this case, I could get out 2 y's. Does everybody understand? Down here, I was just subtracting because I could only get out 1 group. Here I changed it ever so slightly to see if you could figure it out. Is everybody cool? Why did Z not move? Because there was only 1 Z and I was looking for groups of 2. Everybody cool? Yeah? Okay, I'm going to change it slightly and see if you really are cool. Cubed root of 81 x cubed y 5 z 7. Damn, son. That's what the beaver dad said to his beaver kid. Damn, son. Because beavers build dams. This is a deadly one. How many people think they might have an answer? Okay. Yeah? Oh, I was just waiting to see how many people think they might have an answer. Only like 4 hands went up, so I need to wait another moment. If I asked again, would I get more than 4 hands? Please, 1 second. Please notice I did not ask how many people feel they have the right answer. I just want to know if you have an answer. All right. Heyman, I've been very patient with you, but you must realize that I know where you are finding these jokes, right? And you must realize that there is nothing I hate more than mobile devices. And you must realize that I have talked to you numerous times about yours. No. And you must realize that a smarter move would be to put that in your pocket, not even on vibrate, on silent, so you don't even know if you're getting an alert, so you cannot even be tempted. Good. This is 3 to the 4th, yes? X cubed, y to the 5th, z to the 7th. I am looking for groups of what? 3. Can I get a group of 3 here? So what's coming out? 3. What stayed under there? A single 3. Can I get out the x's? How many? 1. Any x's left under there? Can I get out the y's? How many? 1. Any y's left under there? Y squared. Can I get out the z's? How many? 2. Z squared. Any z's left under there? 1. 7. I can take out 2 groups and I leave 1. Can everybody do this with numbers? Yes. Can everybody do this with variables? Yes. Can everybody do this with numbers and variables? Well, fortunately, you're about to practice. Turn the page over. What? I'm aware of that. Turn the page over. Page 32 is your homework.